On the 14th of March, the night sky will showcase one of its most awe-inspiring sights, a total lunar eclipse. This celestial event will be visible across the Americas, Antarctica, Alaska, northeastern Russia, and Africa, offering millions the chance to see the moon transform into a deep red blood moon as it passes through Earth's shadow. This total lunar eclipse will be a must-see event for skywatchers, requiring no special equipment, just a clear sky and a good vantage point. What is a total lunar eclipse? A total lunar eclipse happens when the Sun, Earth, and Moon align perfectly, with Earth positioned between the two. This causes the Earth's shadow to be cast onto the Moon, temporarily blocking direct sunlight. Lunar eclipses don't happen every full moon because the Moon's orbit is tilted by about 5 degrees relative to Earth's orbit around the Sun. Most months, the Moon passes slightly above or below Earth's shadow, avoiding an eclipse. A total lunar eclipse only happens when a full moon crosses the plane of Earth's orbit, an event that occurs roughly twice a year. Instead of disappearing completely, the Moon glows a reddish-orange hue, often called a blood moon, as Earth's atmosphere bends and filters sunlight, scattering shorter blue wavelengths and allowing only red and orange hues to reach the lunar surface. How the eclipse unfolds. The eclipse occurs in 6 distinct phases. Penumbral eclipse begins. The Moon enters Earth's outer shadow, penumbra, causing a subtle dimming that may not be immediately noticeable. Partial eclipse begins. The Moon moves into the darkest part of Earth's shadow, umbra, and a distinct dark curve begins sweeping across its surface. Total eclipse begins. The Moon is completely covered by the umbra, taking on a reddish hue, the most breathtaking phase. Total eclipse ends. The Moon starts to re-emerge, gradually brightening. Partial eclipse ends. The dark shadow fully recedes, leaving behind a faint penumbral shadow. Penumbral eclipse ends. The Moon returns to its normal brightness. Eclipse timing, UTC. For those planning to watch, here's the approximate timeline of the eclipse. Penumbral eclipse begins, 3:57 UTC. Partial eclipse begins, 5:09 UTC. Total eclipse begins, blood moon phase 6:26 UTC. Greatest eclipse, mid-eclipse 6:58 UTC. Total eclipse ends, 7:31 UTC. Partial eclipse ends, 8:47 UTC. Penumbral eclipse ends, 10 UTC. Convert these times to your local time zone to plan your viewing. Totality, the period when the Moon is fully inside Earth's shadow, will last approximately 1 hour and 5 minutes, providing ample time for observation and photography. Unlike a solar eclipse, which requires protective eyewear, lunar eclipses are completely safe to view with the naked eye, binoculars, or a telescope. How to watch the total lunar eclipse. Observing this eclipse is easy. If the Moon is above the horizon in your location, you will be able to see it. Check visibility for your location. This eclipse will be seen across the Americas, Antarctica, Alaska, northeastern Russia, and Africa. If you're in one of these regions with clear skies, you will have a great view. Choose a dark viewing spot. Although the Moon will be bright enough to see from anywhere, a location away from city lights will enhance contrast and detail. Time your viewing around totality. The most stunning part of the eclipse happens during totality, when the Moon glows red. This phase lasts over an hour, so you have plenty of time to observe. Use binoculars for extra detail. While you don't need special equipment, binoculars or a telescope will reveal stunning details of the Moon's craters and surface texture during totality. Capture the blood moon. A DSLR or smartphone with manual settings works best. Use a tripod to avoid blur, and adjust exposure settings to balance the Moon's brightness. Celestial coordinates. Here are the Moon's coordinates at the midpoint of the eclipse. Right ascension, 11h36 m. Declination, +2 degree 50. Constellation, Leo. Angular size, 2944. This eclipse is part of Saros Series 123, a cycle of lunar eclipses that repeats every 18 years, 11 days. Each eclipse in a Saros series shares a similar geometry, meaning the Moon passes through roughly the same part of Earth's shadow each time. The last eclipse in this series occurred in 2007, and the next will take place in 2043.